To provide affordable cars to the people of Pakistan, their small workshops utilize traditional sand casting to make crankshafts. The crankshafts produced through this method are uniformly collected and assembled by large factories. This not only provides employment opportunities for the local workers but also makes the crankshafts a third cheaper than imported ones. Although this method is relatively slow, it can still produce precisely structured engine crankshafts with simple mechanical equipment. The craftsman is preparing the mold for sand casting. First, they place a sandbox on the mold and then fill it with prepared molding sand. To ensure there are no gaps in the mold, the craftsman uses various tools to compact the sand continuously. After the sand is compacted, they smooth the surface of the sandbox with a scraper. Subsequently, two workers work together to rotate the sandbox 180 degrees, remove the upper mold, and evenly sprinkle release powder in preparation for the next step of casting. Next, the craftsman uses a blowtorch to bake the mold to expel moisture and volatile substances, preventing the mold from cracking or defects during metal pouring. After baking, the upper and lower layers of the mold are precisely aligned, and then they wait for the casting process. Meanwhile, in another corner of the factory, the craftsman is busy adding raw materials to the boiler. These raw materials are recycled scrap metal acquired at a lower cost. To ensure the purity of the molten metal, the craftsman carefully removes the impurities floating on the surface. Once the molten iron is ready, the craftsman begins manually transporting the heated iron. They ensure all surface impurities are removed and add borax to the molten iron. The addition of borax improves the fluidity and solidification characteristics of the molten iron, ensuring that the final cast crankshaft meets quality standards. Finally, they carefully carry the ladle filled with molten iron to the casting area. The pouring process must be very cautious to ensure the molten iron completely fills every corner of the mold. After the casting is completed, they wait for the castings to gradually cool and solidify. The craftsman will only start the hot demolding process when the castings have become sufficiently hard. If the castings are demolded only after they have completely cooled, it could cause deformation or sticking to the mold. In further machining, the craftsmen fix the castings on the lathe chuck and adjust the crankshaft to ensure its concentricity. Then, they start the lathe and use a cutting tool to quickly remove the oxidized layer from the surface of the casting. Throughout the entire machining process, the craftsmen strictly monitor the dimensions of each part, using handheld measuring tools for precise comparison. This ensures that every step of the machining is error-free, guaranteeing the precision and quality of the crankshaft. After the initial machining is completed, the crankshaft is transferred to an eccentric synchronous lathe. This lathe allows the crankshaft to rotate around its own axis, adjusting to the most accurate eccentric angle for further processing. Due to the large rotational inertia of the crankshaft, it must be handled very carefully during operation to prevent displacement or ejection while rotating at high speeds. After this step is completed, the craftsman proceeds to drill the flywheel mounting holes at the top of the crankshaft. The crankshaft is placed vertically on the drill press, and a positioning tool is used to lock the crankshaft's connecting flange in place. Once the positioning tool is secured, the holes are drilled precisely on the flange according to the preset markings. This process is relatively simple, following the preset hole positions to ensure each hole is accurately drilled. After drilling the holes, a tap is used to thread them, ensuring that the flywheel can be securely mounted. Once the threading is completed, the next step is to polish the crankshaft to remove any burrs produced during the casting process. Following this, oil passage holes need to be drilled into the crankshaft. The crankshaft is fixed at a 45-degree angle on the workbench. Using a custom-made mold, a guide hole is drilled first. After the guide hole is completed, a drill bit is used to create a pinhole at an angle. These oil holes ensure that the crankshaft has adequate lubrication, allowing it to perform optimally in the car engine. After drilling the holes, the crankshaft is transferred to a milling machine. The craftsman uses a precision dial indicator to adjust the position of the crankshaft, ensuring it is perfectly aligned. Once the position is set, a hob is used to cut a groove on the crank pin connecting rod, preparing it for subsequent assembly work. Although the grooving is completed, the surface of the crankshaft after lathe machining is not yet smooth enough. Therefore, a grinding machine is used to finely grind the surfaces of the crankshaft's journals. This process requires extremely precise operations to ensure that the surfaces of the journals are flat and smooth, meeting high-quality standards. After the grinding process is completed, the crankshaft undergoes a dynamic balance test. This is a critical step where the craftsman, relying on years of experience, evaluates the balance of the crankshaft. Once the crankshaft passes all quality inspections, it is packaged and sent to the engine factory for assembly. It's truly impressive and commendable. Kudos to the skilled Pakistani craftsmen for their excellent workmanship.